Hey guys, welcome to eMaths. Let's do some maths for fun. Today, we will continue the quadratic equation series for part 3. In previous video of the series, we have learned 4 ways to solve a quadratic equation, which are factorization, graphical method, completing the square, and using Brahma-Gupta's formula. In part 2, we covered the complex number system, nature of roots, and the discriminant b squared minus 4ac. Today, in part 3, as promised, we'll finally talk about the new method to solve quadratic equation. Are you ready? Start off. To begin, we'll do this question from part 1 again. But this time, we'll try using the new method so that we don't have to memorize the long formula. X squared plus 4x minus 3 equal to 0, where a equals to 1, b equals to 4, and c equals to negative 3. First, take the negative of 4 and divide by 2. Square it minus the square of an increment k and let it equals to negative 3 from the equation. We will have k squared equals to 4 plus 3, which is 7. Now, solve for k. We will get k equals to plus minus square root of 7. Lastly, we add k and negative 2 together. And that's the answer. Simple, right? We don't even need the formula. But how does it work? We have to first understand the sum of roots and product of roots. Let us recall back the FOIL operation. This is the method we use to find the product of two binomials. For example, bracket x plus p, bracket x plus q. The FOIL operation is to make sure that we don't miss out any terms in the expression. FOIL actually refers to first, outer, inner, and last. What does that mean? When expanding a binomial double bracket, first we multiply the first term in each bracket together. In this case, it's x times x, which is x squared. Then we multiply the last terms in each bracket. P times Q is positive PQ. Next is the two terms sandwiched in the middle. We call it inner terms. P times X is PX. And finally, the two outer terms. X times Q is QX. This is the FOIL operation. Simple, right? As for this part, we can simplify into bracket P plus Q X. And we are done. For quadratic equation, according to principle of zero products, if bracket x minus p, bracket x minus q equals to 0, x minus p equals to 0 or x minus q equal to 0. So x equal to p or x equal to q. Hence, the roots are p and q, no matter they are real or complex. Conversely, if we expand the product of these two brackets using FOIL operations, we'll get x squared minus qx minus px plus pq equals to 0. Simplify, we'll end up with x squared minus bracket p plus qx plus pq equals to 0. Since p and q are the roots of equation, p plus q is the sum of roots, while pq is the product of roots. Now we will generalize this idea. The standard form of a quadratic equation is ax squared plus bx plus c equals to 0. Divide the whole equation by a and compare with the equation we got earlier. We can see that negative p plus q equals to b over a. So p plus q equals to negative b over a. And pq equals to c over a. In general, we can say that sum of roots equals to negative b over a, while product of roots equals to c over a. How is it helpful? With sum of roots and product of roots, we can form any quadratic equation from the given roots. Let's say I want to form a quadratic equation with roots 1 and 4. For sum of roots, it's 1 plus 4, which is 5. For product of roots, it is 1 times 4 equals to 4. As you can see, both b and c are divided by a now. And least common denominator of 5 and 4 are 1. So A equals to 1, B equals to -5, and C equals to 4. Therefore, the quadratic equation is x squared minus 5x plus 4 equals to 0. And that's the answer. Now we understand how quadratic equations are formed by sum of roots and product of roots. We can finally get into the new method to solve. I highly recommend you guys to read out the original article written by Professor Loh. The link is in the description below. Or you can watch his full explanation video on YouTube. To solve the equation that we formed just now, typically, we will first consider the factors of 4 and look out for the combinations that have a sum of 5. The idea of the new method is to flip these two steps. Generally, if it is ax squared plus bx plus c equals to 0, we divide the whole equation by a so that the coefficient of x squared is 1. We let capital B equals to b over a, capital C equals to C over A, and let the roots of this equation be alpha and beta. By concept of sum of roots, alpha plus beta equals to -b, which means the average of alpha plus beta is -b over 2. We can write alpha equals to -b over 2 plus some increment k, and beta equals to -b over 2 minus the same increment k. Then, by concept of product of roots, alpha times beta equals to capital C, and simply multiply these two brackets together. This is convenient because we can use the difference of roots formula. We have b squared over 4 minus k squared equals to c. Now, express k in terms of capital B and C. Finally, we get two values of k. What does it mean? It means we have actually found two numbers that add up to capital B, and the product is capital C, which are alpha and beta. They are also the two solutions of the equation. How do we use this? We try to approach this equation with the exact same steps. Always remember, our goal is to find two numbers that add up to 5, and the product of these two numbers is 4. Let capital B equals to b over a, which is -5, and capital C equals to c over a, which is 4. Let the roots be alpha and beta. Sum of roots is -b. Alpha plus beta is 5. Alpha is 5 over 2 plus some increment k. Beta is 5 over 2 minus some increment k. Product of roots equals to capital C. Sub in alpha and beta. Solve for k. Add k back to alpha equals to 4. And beta equals to 1. That's the answer. Still complicated? Well, I will try further generalize this idea in our second approach. Step 1. Take negative of b over a and divide by 2. Step 2. Square it minus k squared. Let it equals to c over a. Step 3. Solve for k and add to 5 over 2 from earlier. And that's it. Now I'm curious, if we use the factorization method, how many trials and errors do we need to get this question done? To get x squared, because we need one x term in each bracket, possible combinations are x times x and -x times -x. We have two combinations here. To get positive 4, we have a total of 6 possible combinations. Total combination that we have is 2 times 6, which is 12, and it is too much. This is a general idea provided by PreshTalkwalkar about this new method. Divide the equation by a if needed. Consider values of -b over 2 plus minus z. In our case is k. Solve for k by setting the product equals to c. The beauty of this new method is not just you don't have to memorize the hell long formula, but it also works for all types of roots. This is the explanation by Professor Loh himself. It works for any quadratic equation because this method solves the problem by starting from the sum. Let me show you how it works on real and equal roots. I will use the same procedure as the second approach. Take the negative of b over a divided by 2, we get 5 over 7. Square it minus k squared equals to c over a. Solve for k, add to 5 over 7. And we are done. What about imaginary roots? For this evil question from part 2 of the series, same thing, take negative of b over a, divide by 2 equals to 1 over 6. Square it minus k squared equals to 5 over 3. Solve for k and x equals to 1 over 6 plus k, and that's the answer. Still not convinced? Let's do some algebraic proof. This is what we got from earlier, and this is how we define capital B and capital C. Sub them into the equation, get common denominator so that we can combine the fraction. Square root of 4a squared is 2a. Again, combine fraction. And that's our friend, the quadratic formula, proven. Okay, to end this series, I will do a comparison between all 5 methods that we came across in this series. Not that these are just my personal opinion, and I do not represent everyone. The first method we used was factorization method, or the reverse Hoyle technique. Advantage: simple and practical. Disadvantage: only works for perfect square, involves tons of trial and error. Graphical method. Advantage: clear and accurate. Disadvantage: only works for real roots, takes time to plot graph, therefore it is not practical. Completing the square. Advantage: works for all types of roots, provide deep understanding. Disadvantage: super tedious, you can easily make mistakes. Using Brahma-Gupta's formula. Advantage: works for all types of roots, straightforward, can be used even if we don't understand. Disadvantage: need to memorize and provides no insight. Lastly, Poh-Shen Loh style. Advantage: works for all types of roots. It is simple, can be used even if don't understand, but it also provides insight. Disadvantage: may become a rote technique. Of course, the simplest way to solve quadratic equation is still use calculator. That's the end of quadratic equation series. If you like e-maths, remember to check out my other videos. Thank you for watching. See you guys in the next video.